So today we are going to see on the topic force and motion. What in physics we come across various motions of a body. So what causes the motion of an object? The answer we give is always force. And what stops an object under motion? Again, the answer is force. Thus, in general, the force and motion are like two sides of a coin. Example, the interdependence of force and motion is seen in when you throw a ball and catching a ball. So force, just let us discuss about the force. Suppose if we place a ball on a flat surface, it will remain there until unless we disturb it. So it will move only when we push it or pull it. This push or pull acting on an object is known as force. We can see in the diagram the push and pulls. When somebody is applying a force on the material, so it is moving, and we can also pull the material. So whatever we do, we need a force, whether it is an upward force or downward force or side force, whichever whatever it is required. If you want to push or pull, then we need uh, a such thing is called force. A force, a push or pull acting on an object. Forces causes an object to change its speed, direction, or both. So how this force affects on object? Okay, you can see a balloon. Hold an inflated balloon between your arms. Now apply a force on it by pressing your palms. What do you observe? You'll observe that on pressing the balloon, its shape changes. Thus, we can say that on applying the force, the shape of a body can be changed. Can you think of some other effect of force? Yes. While playing football, if you want to change the direction of the moving ball, you will have to kick the ball in a particular direction. And when you kick the ball, you apply certain force to change the direction of the moving ball. Similarly, you can also change the speed of a moving object by applying force on it. For example, the speed of a bicycle can be changed by applying brakes on it while moving. So thus we come to the conclusion the force applied on an object can make the object move from rest, change the speed of a moving object, it can change the direction of motion of the object, or change the shape of the object. So generally, as we said, force is a push or pull acting on an object or energy as an attribute of physical action or movement. This occurs when two entities are in contact. So when two entities are in contact, this kind of things will happen. According to the law of gravitation, every object in this universe exerts a force on others. So the force acting on an object generally is given by the parameter, like if SI unit of force is Newton, kg meter per second square, symbol of force is F, and the quantity usually vector quantity. Dimensional formula is m power 1 L power n T power minus 2, and other units of forces are dyne, pound force, kilopound, uh, etc. Balance, actually the unit of force is generally Newton. Balance, we have two types of forces, balanced and unbalanced forces. Have you ever seen a game of tug of war? Okay, so in this game, when two teams full with equal force, we can see here, and two teams full with equal force, they apply balanced forces on the rope. Then the rope thus remains stationary. When one of the team applies greater force, it is able to pull the other team and the rope towards the side. In this case, the forces are unbalanced. You can see here when the force 300 Newton both the side, then it is the rope remains stationary. Suppose in the left hand side you can see here 400 Newton, and this side here you can see right hand side 300 Newton. So the force this side left side is more, so the rope towards they can pull the team to the other side. So that's in that case the forces is considered to be unbalanced. Another example you can say is, suppose if you place a brick on a table, push the brick towards left with your right hand. What do you observe? The brick begins to move to the left direction. Now push the brick towards right with your left hand, in which the direction moves this time. Now push the brick from both the sides with equal forces. In this case, you will observe the brick does not move in any direction. Can you think why? The brick does not move in this time. In fact, in this case, the two forces balance each other. Such forces are called balance forces. So what type of changes can be produced by balance force? So when there is a balance force, what can be changes to the object happens? The balance force do not change the state of rest or motion of the object on which they are applied. That's the balance forces are forces acting on an object from opposite direction that are equal. These objects with balance force acting on upon them will most likely to still not moving. Then we come to the unbalanced force. So next one is the unbalanced force. What happens when two opposite forces acting on the brick or different magnitude? Already we discussed here. So here 3 newtons and this side you are having 4 newtons and 4 newtons of the force. So if the same thing is applied to the brick would begin to move in the direction of greater force. Such force are called unbalanced force. So what this unbalance will do may change its state of rest or motions. So the unbalanced forces are forces of acting on an object from opposite direction that are not equal. This object with unbalanced force acting upon them or in motion that is moving. So we have other types of forces generally we come across in day-to-day life, which is contact forces and non-contact forces. Here the example for contact forces are frictional force, normal force, tension, spring force, applied force and muscular force. So muscular force is usually exerted by muscles like lifting a weight. We also have applied force. So suppose the force exerted on a object by a person or on another object like pushing a box, etc. And we have tension force also. Tension force is transmitted through a rope, string or cable when pulled tight, like pulling on a rope in a tug of war. That is a tension force. Friction force, that is the opposite motions. The opposes when two objects rub against each other, like a box sliding across a floor. Here where skating is the best example for the frictional force. So these are the contact forces. And when you come across non-contact forces, we have gravity, magnetic force, electric force, nuclear force. The magnetic force is usually exerted by magnets on magnetic material, and gravitational force is force of attraction between objects with mass, causing object to fall towards the earth. And electric force exerted by electric charges. So whenever we are using a comb, when you are combing that, there will be a charge creating in the bits of the so a charge of comb attracting the bits of paper. That is a kind of electrostatic force. A nuclear force that holds the nucleus of an atom together. That is a kind of so gravitation. We know that apples falling towards it due to gravity. These are some of the examples of non-contact forces. So other than that, suppose a particle is immersed in a fluid, there are other forces acting on the small particle. That is a gravitational force, buoyancy force, and drag force. So the both buoyancy force and drag force are upward force, and gravitational force is the downward force, which pulls the object towards each other. And buoyancy force and upward force exerted by a fluid on an immersed object, and drag is a force that opposes the motion of object through a fluid. Then consider to be a mode. Next we'll discuss about these are all about the force. So when we talk about motions, both are interdependence. The motion, whenever a body is moving, we say it is motion. For example, if a body is walking down the street from, suppose a boy is walking down the street from his school to his home. If when we'll say the boy is in motion, but if imagine if the boy stops for 5 minutes in the way and sit down, then if someone asks that time if the boy is in motion, the answer will be definitely no. So from this what we can infer that the motion of a body is dependent on time. In physics we say that motion is a change in the position of a body with respect to time, and usually it refers to the movement of a body. Motion can either be described as change in speed or change in direction, which is acceleration or velocity. Then the important term when you talk about forces and motion is inertia. What is inertia? Could have seen that whenever we shake the branches of a tree vigorously, the leaves and fruits get detached. Similarly, when you beat a carpet with a stick, you will see the dust particles getting detached from the carpet. Do you know why? The answer is inertia. Now we'll discuss what is inertia. Inertia is a tendency of objects to stay at rest or to keep moving with the same velocity. Some more examples of inertia from our daily life are uh, a sprinter keeps running for some time even after crossing the finish line. Similarly, you can notice that it is difficult to take out the tomato sauce from the bottle by just inverting it. But it is easy to take out the sauce from the bottle by just giving a sudden jerk to it. By moving the bottle in the downward direction, the sauce comes in motion. But when the bottle stops suddenly, the sauce remains in motion due to the inertia of motion and comes out of the bottle. So, so those are all some of the example of inertia. So inertia and mass are interdependent. Due to inertia, generally an object offers resistance to change its state of motion. Do all the objects have the same inertia? These are the some of the questions we are getting in mind. For example, push an empty box on a smooth surface. Now try to push a similar box full of books on the same surface. So what happens to that? That is a question. What do you find? Why it is easier to push an empty box than a box full of books? Now suppose you are asked to stop a table tennis ball and cricket ball moving with the same velocity. On which ball you are supposed to apply more force to stop it? You will find that the cricket ball require more force to stop as compared to the table tennis balls. Thus, all the objects do not resist a change in the state of rest or motion equally. So, massive object resists more than the lighter ones. So, from this conclusion, from this what we are observing is that mass is a measure of inertia. So, inertia, in a cut short, we can say it is the stubbornness of an object to stay at rest, stay in motion, or stay moving in one direction. Next, we'll discuss about Newton's law. The Newton law of motion is depends on this law of inertia. Nothing moves from sitting, stops from moving, or changes direction without an outside force acting on it. That is a Newton's law of motion, which is also called law of inertia. So we'll discuss this with an example. Take a smooth sheet of paper and place it on a table with some part of it coming out of the edge of the table. Now place a glass filled with water on the paper. Remove the paper with a jug. What happens? You'll find the glass remains in its position. The inertia of the glass prevents it moving with the paper. Now, in brief, we can discuss about Newton's law of motion. An object offers resistance to change in its state of motion. As we discussed, this was clearly studied by the scientist Isaac Newton, which governed the motion of objects. There are various laws he framed. First is first law of motion. Every body continues its state of motion, rest or of uniform motion in a straight line until unless it is compelled by some unbalanced force to change that state. So Newton's first law of motion tells us that all bodies resist a change in the state of motion. So this property of bodies is called inertia. That's why it is called as law of inertia. So you can see this example. Why do passengers standing in a bus fall in the backward direction when the stationary bus begins to move suddenly? Passenger falling in the backward direction when the bus starts suddenly. This observation can be explained on the basis of first law of motion. So the feet of the passenger are in contact with the bus. When the bus starts suddenly, the feet starts moving with the bus, but the upper part of the passenger try to remain at rest due to inertia and tends to fall in the backward direction. So that's the reason. So what happens when moving bus stops suddenly? In this case, the passengers standing in the bus fall in the forward direction. Can you think the reason of it on the basis of explanation? Yes, the force required to stop a moving body depends on its mass. Now we can just see another two example also. Suppose two balls of same mass are moving at different velocities. Which ball will need more force to stop? You'll find that faster moving ball require more forces to stop. Thus, the force required to stop a ball also depends on its velocities. A small bullet, when fired from a gun, can kill a person, but the small bullet, if thrown with a hand, can hardly do any harm. Another example we can see is a truck parked along a roadside does not require any attention, but a moving truck may kill a person standing on its path. It is only the velocity of the truck which makes us the frightened. So if it is though, then a toy car moving with the same velocity as a truck would have equally frightened us? No. From this observation, it is observed that the impact produced by the object depends on the mass and the velocity. These two quantities are combined to form a term called momentum. What is a momentum? Momentum of a moving body is defined as the product of its mass and velocity. The SI unit is kg meter per second, and momentum has both magnitude and direction. Its direction is same as that of the velocity. So the next we discuss about Newton's second law of motion. According to Newton's first law of motion, the application of unbalanced forces bring a change in the velocity of an object. Thus, the force can produce a change of momentum. Now, Newton's second law of motion establishes a relationship between force and change in momentum. Second law of motion states that the rate of change of momentum of a body is directly proportional to the force acting on it and takes place in the same direction as the force. So now Newton's law of motion also give a relationship between the force and the acceleration. F is equal to ma. The unit of force is Newton and symbol is n. While catching a this is an example we can say. While catching a fast moving cricket ball, why does the fielder move towards its hands backward? By doing so, the fielder increases the time duration in which the momentum of the ball becomes zero. As the rate of change of momentum decreases, a small force is required for holding the catch, so the holder of the fielder do not get hurt. So the force can accelerate the body, the force deaccelerate the body, force can change the direction of the moving body. So these are some of the examples which explain that. And motion is explained using a law of motion and is defined as particles behavior when in motion and is given by S is equal to S naught V naught T plus half AT square. S is the position of the particle, in S naught is initial position, V naught is initial velocity, A is acceleration, T is the time. So the forces and motions are two heavily connected entities. The force can result in the acceleration, deacceleration, change in direction or total cessation of the motion. Newton's third law of motion we'll discuss now. So what is Newton's law of the for every reaction there is a opposite equal and opposite reaction. When a rubber balloon filled with air is released, what happens? The balloon moves opposite to the direction of air coming out of it. Why does the balloon move in direction opposite to the direction in which the air escapes? We must notice that when you jump from a boat to the river boat bank, the boat moves in the backward direction. Why this happen? So this question we can answer now. While jumping out of the boat, your foot exerts a backward force on the boat. This force is called action. At the same time, a force is exerted by the boat on your foot which makes you move forward. This force is known as reaction. Remember, when two bodies and two forces are involved in this problem, you push the boat backward and the boat pushes you forward. These two forces are equal magnitude but opposite in direction. The same example we can apply for the balloon also. So Newton in his third law of motion stated a relationship between action and reaction. According to this law, to every action there is an equal and opposite reaction. The action reaction acts on two different bodies. If action reaction on the same body, they will constitute a balanced force and the body will not move. Here the balloon moves opposite direction in which the air escapes. So there are three significant features of the third law of motion. We cannot say which force out of two forces the force of action and which one is the force of reaction. The forces are interchangeable. Action reaction always act on two different bodies. So the action and reactions are interchangeable. So action reaction always act on two different bodies, the force of reaction appears so long as the force of action acts. Therefore, these two forces are simultaneous. It is not necessary that two bodies among which the force of action reaction act or in the contact, they may quit far from each other. For example, attraction repulsion between the two magnets can take place even without being in contact. Now we will see the another concept called thrust and pressure. So, we observe some bodies around you like table, desk, bucket full of water, etc. They press the floor with the force equal to their own weight. Do you know what? The weight is a force acting vertically downwards. As the surface of the floor can be taken as horizontal, therefore the force with which each of the above mentioned body presses. The floor is directed perpendicular to the surface of the floor. The force acting on the surface of a body perpendicular to it is called thrust. It's not thrust, TURST thrust. The action of the given thrust depends on the area of surface it acts upon. Smaller the area on which the thrust acts, the more evident is the result of its action. Thrust on unit area is called pressure. The pressure is equal to, so thrust on unit pressure by area. So here some correction is pressure by the thrust by area is called pressure. There is a small mistake here, and also the spelling is also is a small mistake here. Thrust and pressure. Take a small, so example we can say we take a small wooden board with four nails fixed at each corner. Fill a tray with stand to depth of about 6 centimeters. Place this wooden board on stand with the nail heads downwards. What happened? Also put suppose 500-gram weight on the board. Observe the depth of the nails up to which they penetrate into the sand. Now place a wooden board on the stand with the pointed side of the nail facing downwards and put the same weight on the board as in the previous case. So again observe the depth of the nail up to which they penetrate into the sand. In which of these two cases the penetration more? The penetration is more in the second case. So next we will see about friction. There is another term called friction. A ball rolling along the ground stops after moving through some distance. Suppose if you are rolling a ball around the ground, it stops after some distance. Why? What? Similarly, a moving car begins to slow down when its engine is switched off and finally it stops. Why does it happen? This is due to the forces of friction. According to Newton's first law of motion, a moving body continues to move along a straight line until unless an external force is applied on it. The friction exists between the surface of all materials which are in contact with each other. So, friction exists between the surface of all materials which are in contact with each other. The direction of frictional force is always in a direction opposite to the motion. So, try to analyze the forces acting on an object moving with a constant velocity. Suppose if an object is to be moved with a constant velocity, a force equal to the opposing force of friction must be applied. In that cases, two forces are balanced. They exactly cancel one another and net force on the body will be zero. Hence the acceleration produced. In the body in the body is zero in the is hence the acceleration produced in the body is zero. The body maintains its velocity. It neither speeds up or nor slows down. The resistive force before the body starts moving on surface is called static friction. Once a body starts moving on a surface, the friction between them is called sliding or kinetic friction. The sliding friction is always slightly less than the static friction. Next, we will see about some one small example of a friction. Set up an inclined plane on a table as shown in the figure. Mark a line near the top edge of the inclined plane. Now hold a pencil cell on this line. Release the pencil cell. What do you observe here? The cell moves down the inclined plane and continues to move for some distance on the table. Note down the distance up to which the cell move on the table. Next, now place a glass sheet on the table. Now again, please release the pencil shell from the line on the inclined plane and note on the direction to which the cells moves on the glass plate. Repeat this activity spreading a uniform layer of sand on the table, in which case the distance covered by the pencil will be maximum. What do you conclude from this activity? You'll find that the distance moved by the cell is maximum on the glass surface and minimum over the sand. Different is due to the friction offered by different types of surfaces. The smooth surfaces offers less friction compared to a rough sand bed. So the smoothness of the surface is one of the factor on which the friction depends. So that's all about all these things. This was the summary. What is the force? What is the motion? And the relationship between the force and motion, and what are the laws and types of forces we have discussed, and the momentum of a body is a product of mass and velocity, and we also discussed about friction and thrust and pressure,